Happy Monday. This is section 16.5 on relative motion analysis. I've just gone ahead and drawn out the first diagram, figure A, you'll see if you open that section. And this shows that we have a fixed frame, an inertial reference frame, and from that we can measure our translating point, or what we're going to call our base point, and in this case A. We have some sort of beam or member, and we call that member AB. To start looking at the velocity of how this whole thing is going to move, remember general plane motion was equal to a translation plus a rotation. So right now all I'm talking about is just the translation from the fixed inertial reference frame, which is this thing right here. Okay, so we have coordinate axes y and x, and y prime and x prime, and all of that coordinate axis has to do with is the translating point. So we normally wrote r of b with respect to a is equal to r of b minus r of a. That was just the way that makes more sense to me. But now we're going to have to go to this version, because I'll get to it in a second when we look at velocity. This is your book definition for the motion of B with respect to A using position vectors. But what we want to look at is the differential movement. dr of B is equal to dr of A plus dr of B with respect to A. And so what do these differential movements come from? If we look at A, the movement of A is strictly from a translation. The movement of B with respect to A, well, let's draw something out first. Let's say I want this beam to first translate over like this. So here's our A, here's our B. So everything translated over, and then I want this to rotate through like so. So this is our final position. Okay, we can describe the position. Ooh, let me re-letter this. We can describe the motion of B by saying we have a translation at A. A, just slide it over to a new spot. And then we had some rotation, and that rotation is our differential movement of B with respect to A. So we can say it's caused by a rotation. And this is our general plane motion then, which is equal to a translation plus a rotation. Okay, so I think the next step would be to take the time derivatives, and we get dr of B dt is equal to dr of A dt plus dr of B with respect to A dt. And what do we get? We get the velocity of B is equal to the translating velocity of point A plus the rotation that we get about A at point B. So the translation of A, and then we look at the motion of B. So B swung through due to some circular motion, and we get a velocity of B with respect to A. Those combined give us our general plane motion. And since this is a circular path right here, right, if we look at how B moves with respect to A and if A and B are a fixed distance like they are, then this has to be a circular path. So v of B with respect to A can be written as omega crossed R of B with respect to A. So the velocity of B is equal to the velocity of A, that's this part, plus omega crossed R B with respect to A. Okay, so I really recommend looking at this whole entire chapter. We're going to see a lot of things where we may have a piston arm connected to a piston that has to go through in this manner, and we have some rotation about some fixed point here. We know where points A and B are and C, and using what angle we're at, using the omega that we know, and using our position vectors, we can describe the motion. So A in this case is fixed to move horizontally while B moves in a horizontal path. So A would be our translating reference point in this one. And as A moves in and out, let's say A came out to here, B would be up at a higher position, right? So we get a rotation also. And then another interesting one is looking at a wheel rotating on the ground. So we can say this is a fixed point. It's not moving at all. The velocity of A down here is equal to 0. We'll call B the center point. And if the whole vehicle is moving, or system is moving, that's on these wheels with some velocity of B, and we know omega, this velocity is just equal to R omega. So we're looking in this case as a wheel that is translating with its fixed point, and then it rotates through to a new point. Always try to think of general planar motion as a translating motion from one point that we usually call A, and then a rotation about A to describe point B. Alright, and this is how we're going to do it. Thank you.